Checksum-based storage. Why are we bringing up checksum-based storage as part of this discussion? Well, because Artifactory uses a checksum-based storage approach for storing the binaries. This is very unique to our product. It involves two pieces, a database and a file store. Every time a binary is uploaded into Artifactory, a unique SHA-256 checksum is created with an algorithm. It pulls in various component details about the actual artifact itself that is being uploaded. It stores the binary as a SHA-256 in the file store, and then it references it via metadata. This allows a couple different things. First of all, deduplication. So if you have 1,000 projects, all using one common core library among those 1,000 projects, we actually store the library only once and we reference it 1,000 times in the database. This means that if you move binaries between, say, repositories or locations, you're simply moving metadata, as they are simply a pointer. If you delete files, you're simply deleting the metadata because there might be multiple references to the same library or binary itself. In terms of replication, we also use replication between locations, which we'll discuss in a further chapter. But for uploads and downloads and for replication, we actually will use a checksum-based storage approach, meaning that the source and the target will communicate, and the source will actually say, here are a bunch of the files I wish to send you. Here are their checksums. It'll match those checksums up against the remote side and make sure that there's no duplication and only transfer the ones that are the deltas between the two versions. It also increases the performance. Since all your interactions are done via the API or the CLI, one of the things that's nice about this is that you're actually using the metadata to do it, then retrieving the actual component afterwards. The thing is by using the metadata-based approach, it allows you to do simple search, allows you to also add additional metadata to every single binary that you have inside of Artifactory to even make it more contextually relevant. So when you look at the checksum-based approach, you can see, if we were to actually look at the physical file, you can see the actual physical file itself, and we create a corresponding database entry, and in that database entry, we have a link to the SHA-256 value that's in the file store, the name of the component, where it's stored in which repository, and the actual file path itself. And it's actually delivered this way down to the actual request once it's been fulfilled. So the thing is that since everything is based on a checksum-based approach, everything can be very transparent and very automatic. It forms a strong bond between the actual artifact and the actual binary itself. There's a lot of metadata context, everything about it, like how it was implemented, its license file, and additional information. And you can also layer additional information that you can use as queryable and actionable things later on. And on top of that, since it's all stored in a relational database, that means that it's easily accessible, easy reproducible, and you can also back it up. But the checksum-based approach storage, really one of the major things about it is speed, accuracy, deduplication, replication, metadata, move, copy, delete, all that are actually easy actions because they're metadata, but speed and efficiency is the key characteristic and the reasons why we chose checksum-based storage as one of the main core components behind the Artifactory product.